Now let's apply congruency to some theorems. First, let's define theorem. A theorem is a statement that must be proven. It's justified using logical reasoning. So let's take a look at congruence of segments. Congruence of segments is reflexive. That means that a segment will be congruent to itself. It's going to have the same length as itself, which hopefully makes sense using logical reasoning again. Congruency is also symmetric, which means that if AB is congruent to CD, then CD is congruent to AB, which just allows us to switch that order around. We have symmetric also with equality. Now we have it also with congruency. And last one with transitive, if AB is congruent to CD and CD is congruent to EF, so if you are given those things, then AB must be congruent to EF. If they're both congruent to the same segment, then they must be congruent to each other, and that's the transitive theorem. So theorem 2.1, 2.2, and 2.3 are properties for congruent segments. So in this example, we are told that SW is a length of 15 inches. So I'm going to label SW as 15 inches. I know that SW is congruent to YK. So SW, I make a little congruency tick mark, is congruent to YK, which means that this is also 15 inches over here. And I guess that kind of answers the question. Like, so then what does YK equal? Well, by the definition of congruency, YK also equals 15 inches. In this example, we're not given any values, but it does say that VZ is equal to KY, so their segments are the same length. I don't know what those lengths are, but they are the same. But then it's saying, okay, well then that means KY must be congruent to, well, if it's the same length as VZ, then it must be congruent to VZ by definition of congruency again. Go ahead and try this one on your own. Hopefully you found that VZ is equal to 17. Okay, one more vocab term with some examples here. So the midpoint is the unique point that separates a segment into two congruent segments. So midpoint is exactly in the middle. It's going to separate a segment into two congruent segments. So in this case, example, figure M is the midpoint of PQ. That tells me that 2x minus 5 can equal x plus 7. It tells me that PM is congruent to MQ. Okay, that's what it means to be a midpoint. It is separating it directly in the middle, so we can set the two equal to each other. 2x minus 5 equals x plus 7 to find the value of x. So this example looks a little bit more confusing. Let's see if we can figure it out. It says find the value of x given M is the midpoint of AB. So if M is the midpoint of AB, that means that AM is congruent to MB. And so we are asked to find the value of x, but we're also asked to find the length of MB. We've got a lot of things going on here, but it does say that AB equals 52 inches. So if the whole thing equals 52 inches, then by definition of the midpoint, this piece up here is 26, and this whole piece down here is also 26. We'll see if I can use that to find the value of x. Now, I actually do have a lot of options here. Since I know the length of the entire segment of 52, I can technically add this 2x minus 3 plus this 5x plus 1 plus 6x plus 2 instead of equal to 52 and solve. I can also add these two segments together, these two pieces together, to set them equal to 26 because they represent this segment here, this piece of the segment. But then I can also do the same thing over here. 6x plus 2 equals 26. And I don't know about you, but out of everything I've mentioned so far, that sounds like the most simple equation to solve for x. So I'm just going to go ahead and do it. So x equals 4, and it looks like actually we've answered both pieces. We found the value of x, it's 4. We also found the length of MB simply by dividing that 52 by 2. So MB is 26, and the value of x is 4. So this concludes the video lessons for congruent segments, talking about midpoint and by definition of congruence and a little bit of those properties and theorems that come along with it. So if you have any questions, don't forget to re-watch the video as many times as possible as you need, but then also to ask. Okay, thanks for watching.